All right. So one thing is that the cryptography is a lot of math. So you saw the confusion part of the cryptography, but you haven't seen the math part of it. And we need to get into the math part. So this chapter is about that math part. Okay. I think there are a few more chapters like this, which is, and then we get into protocols and things like that. How do you apply these in the different protocols? How Wi-Fi does it? How DNS does it, and all that. So, but number part is here. So here, this could be just a math class, actually, in some sense, this chapter. So we'll talk about the Euclidean algorithm for GCD, greatest common divisor. We'll talk about modular arithmetic, how to do mod 2 arithmetic. We'll talk about groups, rings and fields, Galois fields, and polynomial arithmetic. Okay, so first of all, let's talk about the greatest common divisor, GCD. So GCD is basically the greatest common divisor for 10 and 25 is 5. Right? And I don't know whether they teach in high school, but they taught me in this high school, and please tell me where you learned this. But basically, if somebody asked you to find out what is the GCD of 10 and 25, the way you do is, one simple way would be just to factorize 10 and factorize 25 and take whatever is common. So 10 is 2 times 5, 25 is 5 times 5. Greatest common thing is 5 there. So that's the answer. But generally, we would not do that because, you may not be able to factor things. So what you do is you take the 25 divided by 10, and then whatever, remainder you get, in this case the remainder is 5. You divide 10 by that number, and then whatever remainder you get, you divide that into the previous divisor. You keep doing this until you reach the 0. The last divisor is the greatest common divisor, GCD. So let me ask this: how many people have seen this division method of GCD before? Anybody? 1, 2. That's it. So how many people have seen GCD before? So everybody has seen GCD, and how did you do it? You don't remember? Yeah? You can keep subtracting? Okay, well, I'm subtracting it, but I'm dividing and then subtracting, dividing. No, like that. It's this division, okay. So maybe I haven't seen the subtraction method, but this is the method, this is the Euclidean method. And we are going to do this Euclidean method using using a table. So basically, we write a table and we say, okay, there are 4 columns in the table. First column is called the quotient, second column is called the remainder, and this is ui and vi, okay, something, okay, and then so it will become clear as to what ui vi is, just some intermediate variables. And we start with 10 and 25. So we write down the bigger number first and the lower number second, and we write down 0, 1, 1, 0 here. So these 2 lines you can write right away without doing any math. Basically, these are given. Bigger number, smaller number, 0, 0, 0, 1, 1, 0. Alright, now we start the process. We divide 25 by 10. So we take the whatever is in the remainder column, divide with the previous remainder, previous whatever in the here, so we get 2, that is the quotient is 2, remainder is 5. Right? Quotient is 2, remainder is 5. And then multiply this Ri by Qi plus 1. Okay, so Ri is this 10, Qi plus 1, 20. Okay, and subtract from Ri minus 1, subtract from 25, that gives you 5. So that is, we got the 5 by, I already said that basically. You got the 2 times 20, 2 times 10 is 20, subtract from 25, you got 5. So that we already got. Now next thing you do is multiply ui by qi plus 1 and subtract from ui minus 1. So you just do the same thing but on this column here. On this column, we have 1, we multiply it by 2 and subtract from 0. So we get minus 2. What we did in the previous column, we do the same thing on this column. Take 1, multiply by 2 and subtract from the previous row, you get minus 2. Same thing you do here. You take 0, multiply by 2 and subtract from the previous column, you get 1. Alright, so first question to you, do you feel comfortable? Do you know how at least we got 2, 5, minus 2 and 1? Everybody. If you don't, please ask me right now. It's a good time to ask. How we got 2? By dividing 25 by 10. That was the quotient. And then the remainder became 5. How did we get minus 2? Now we using this quotient and the previous line, basically. So 1 times 2 subtracted from 0 is minus 2. 0 times 2 subtracted from 1 is 1. Once you got the third row, you just repeat that process, basically. So you take 5, divide into 10, you get a quotient of 2. That we got the number 2 by dividing 10 by 5. Now what we do is we do this steps. First we take 5 times 2, subtract from 10, we get a 0. We take minus 2 times 2, get minus 4, subtract from 1, we get 5. 1 times 2, subtract from 0, we get minus 2. Alright, so everybody can get the fourth row. Now you will notice that in every row, this is true, that the remainder in that row is equal to u value times x, which is x is right here, plus v value times y. So if you take 0 times 10 plus 1 times 25 is 25. 1 times 10 plus 0 times 25 is 10. Minus 2 times 10, minus 20 plus 1 times 25 is 5. So Ri is equal to uix plus vi for all i's. Right? That means ui equal to ui minus 2, and this is, so these relations are true. Ui is equal to, this is by design, ui is equal to ui minus 2. So if you want to figure out how is this related to that, minus qi ui, this is how we wrote it in the first place, so that's fine, and so on and so forth. So finally, if Ri is 0, if you get 0 in this column, that means the GCD is the previous remainder, 5. If you get a 1 in any column here, in the remainder column, then the previous remainder, then, sorry, if you get 1 in this column, then ui is the inverse of x in mod y arithmetic. Okay, I'm going to explain that in a minute again one more time, but let's say we don't have 1 here, so we cannot say this one. But if there is 1 here, then ui is this number, would be the inverse of x, 10, in mod 25 arithmetic. Y is this, 25. So if you would have gotten 1 here, then this number would be the inverse. Now what is the inverse means? Inverse means that if you multiply that, you get a 1. So let's see mod by arithmetic in a minute. Let's see. So let's just do this example one more time, and you can do it on your paper. 0, 15, 0, 1, 0, 8, 1, 0. So 8, you can fill in some number. What will come here? How many times will it divide? What is the quotient? 1. And the remainder would be 7. Okay. And here we will get 0 times 1 minus 1 would be minus 1, right? And same thing here, 1 times 1 would be 1, minus 0 would be 1. So we will get a 1 there. So just fill in the next 2 rows just to feel comfortable, and then we go on to the next one. Alright, this is the correct answer. Now, the main thing I wanted to do was have this example of 1. So, we do have an example here where Ri is 1. Right? So, that means when you get a 1, that means Ui, you see, then Ui is the inverse of x in mod y arithmetic. This is the thing. Here is a 1, Ui is 2 equal to 8 raised to minus 1 mod 15. Okay, is this correct? Yeah, it is correct, because you see, if you bring 8 this time, that will become 16 equal to 1 mod 15. That is correct. 16 mod 15 is 1. 16 mod 15 is 1, right? And so, if you wanted to divide any number by 2, instead of dividing by 2, you multiply by 8. You know, anyway, other way around. So, that's all I wanted to do today. And so, you have this homework 4A. This you do not have to submit, but you can just try it out. The question is find the multiplicative inverse of 5678. So you can just do this table again one more time and find out. You will find the answer is 2527. Okay. All right. Then we'll continue on the modular arithmetic next time.